now we're done with supervised learning. I've already gave other fewer examples before, so I'm not going to talk about this. These are some regression models, but they exist already. For example, the car plane navigation, self-driving cars for self-driving cars, and etc. The second type of learning is called unsupervised learning. Unsupervised, as you saw before, in order to learn in supervised learning, we had to give the labels to these data in order to classify or to sort of regress into them. But in this case, we want to learn something from this data without actually giving them anything. We don't want to label them. We just want to give, for example, images, and we want to know what's the difference, or what can we do with that. So let me jump in a little bit further so that we understand. So as you can see here, those are the types of ways we could use unsupervised learning. For example, unsupervised learning is very common for clustering. We have two famous algorithms here for clustering, which one named K-means and the other one named hierarchical clustering. And then we have word embedding, which is a very, very common way to embed words into vectors these days, and it's used almost by any machine learning or deep learning algorithm. There are two models out there, one called word-to-vec and the other one called GLOV. And then we have other dimensionality reduction such as PCA, and then we have topic modeling such as LDA and LSI. And of course other models that we couldn't discuss here. So here is a small picture of clustering. So this is how clustering look like. We have, for example, a lot of data on our graph, and then we want to separate them into three different groups in this case. And then word embedding is we have a space, and we want to put words into that space. And then the difference, for example, these 2 points, the distance between these two words represents the similarity of these two words, or the relatedness of these two words. So, for example, as you can see here, sea word, dolphin, and turquoise are closer to each other, and that's because they have similar meanings. And then camera and Paris are far away from each other, and that's why they are not the same as these three. And that's why. I think the next, the few next videos, they will be talking about this, and you could check them out. So, and then finally we have reinforcement learning. Reinforcement learning is basically just like when we want to learn games, or just like maybe you have heard about AlphaGo, which is the algorithm that beat one of the top players of the game that is called Go. And it uses reinforcement learning because what is basically reinforcement learning? Well, reinforcement learning takes, so for example, the algorithm will try randomly, and then it will not remember these steps. So for example, it goes, let's say we have a maze, and we want the computer to get out of that maze. So what it does is basically it goes left, right, straight, left, 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 straight, and then it learns that, oh, this is a good way, it is leading me to somewhere. So it will rate that as good. And then if it does something bad, then it will label itself as bad. But because the computer doesn't understand good and bad, but we can use values for that. For example, +5 when it's doing good, and -5 when it's doing bad. There is a very, very nice video that explains, for example, how reinforcement learning is working. And this is a robot that they ask him to walk from point A to point B, to go from point A to point B, but they don't tell him how to do that. They don't teach him how to walk, they don't teach him how to run, they don't teach him anything. They just tell him go from point A to point B. And they give him, of course, sensors that tell him if he, for example, when he falls down, then this is not good. So he will use these sensors to know if he's achieving his goal or not. And then they iterate again and again and again and again. And so it takes a very, very long time to learn these type of models. And then once they are trained, they can be used to do a lot of stuff. So after we are done with most of the types of learning, such as supervised learning, unsupervised learning, and reinforcement learning, we have other types of learning, such as semi-supervised and active learning. Semi-supervised is basically self-explanatory. It is a mix between supervised learning and unsupervised learning, and then we have active learning and other types of learning. You could read more about these in machine learning articles or stuff. Just look them up on Google. And then we have the two different types of learning, which is online learning and offline learning. Offline learning stands for basically when you learn from your data set. You have a data set, you learn something, and then you can't learn with other examples. Basically, Once you learn, that's it. You can't unlearn or try to learn or fix any problem out of in your model. And then an online model basically can correct itself. So if once you train, you can give it new data, and then it will learn again from that data and then correct itself. So that's what's the difference between online learning and offline learning. Some of the most common machine learning algorithms. We have linear regression, which we saw a few slides back. In our, and then we have logistic regression. We have decision trees, SVM, naive bias, k-nearest neighbor, k-means algorithm, random forest, dimensionality reduction, such as PCA. A lot of these are very famous, very common, and any scientist in computer science or machine learning needs to actually know these in order to move on to research or something like that.